Using the definition of derivative, find the derivative of the function, state the domain of the function and the domain of its derivative. Well, first of all, let's do the domain of the function. So this function could also be expressed in radical form like this. So we can see that, so we're not square rooting a negative, x must be greater than or equal to 0. Now, as we find the derivative function, in the past we were interested in finding the slope of the curve at some given x equal a. But now we are interested in finding a derivative function, then we could put in various x values and find the slope of the curve at various x's. So we have the limit as h approaches 0 of the function at x plus h minus the function at x all over h. Notice it's much like our other definition, but instead of specifically putting in x equal a, we put an x in each of those places so that we get a function of x. So applying this to our specific function that we've been given here, we have x plus h to the 3 halves minus x to the 3 halves all over h, and I left off we have the limit as h approaches 0. That's important. Now I can't directly evaluate this because I'll be dividing by 0, so I want to see what I can do algebraically to manipulate this to get something that I can directly evaluate. The numerator actually is the difference of cubes, and let me rewrite it so you can see that. I have x plus h, I could write that to the 1/2 and then cubed, and that's equivalent to x plus h to the 3 halves. And then I could also write the next function as x to the 1/2 to the 3rd, and then that's over h. So there's our difference of cubes. This is something cubed minus something cubed. So let's remember from algebra how we factor the difference of cubes. And as I do that, I'm also going to express this in radical form. So if you remember the difference of cubes, you figure out what got cubed and what got cubed for the first factor. So the first part is x plus h to the 1/2, which I'm writing as the square root of x. And the other thing that got cubed was a square root of x. Then for the other factor, you take the first guy and square it, so that's x plus h. Then you multiply these two together but change the sign, so that's plus, they're both underneath the radical, so x times x plus h. And then the last one squared, so that's plus x. And then that's all over h. Now as I'm looking at that, I still can't directly evaluate, so did I get anywhere? And I actually did, because now I'm going to multiply numerator and denominator by the conjugate of this factor in the numerator. And so that's going to be the square root of x plus h. Conjugate has opposite sign in the middle. And of course, to keep it equivalent, whatever I do to the bottom, or to the top, I've got to do to the bottom. And now let's go ahead and multiply this first and third factors, the conjugates here. And we have the limit as h approaches 0 of first times first will be x plus h. Outers and inners of conjugates cancel. Last times last will be minus x. And then rewriting this, I've got two x terms here, so I can write 2x plus h plus the square root of x times x plus h, and that's all over h times the square root of x plus h, I don't need that right there, minus square root of x. There's the other parenthesis. Now, did we get anywhere? We actually did, because we can cancel these. Now we're left with a factor of h multiplied by this other factor, and so that h can cancel with this h. Now we do have something that we can directly evaluate, and we won't be dividing by 0. So let's do that. We have this h is going to go to 0. This h is going to go to 0. So here we have 2x, and here we have the square root of x squared. Now I have to be careful if the x is positive or negative. We have that absolute value, but wait, we have actually our x is going to be greater than or equal to 0. So this is going to become another x, and we're going to have 3x in the numerator. Looking at the denominator, this h is going to go to 0, so we have and I messed this sign up. This negative should be a positive because we needed to do the same thing to the bottom we did to the top. Use the conjugate. So this should have been a plus. So we have the square root of x plus the square root of x, so that's 2 square roots of x. Now we can simplify that. That's going to become 3 halves, and this is x to the 2 halves minus x to the 1 half, so that I can just simplify those. So that's going to be x to the 1 half, which is the square root of x. So here is our derivative function, 3 halves square root of x, and our domain for our derivative function is also x must be greater than or equal to 0.